Very good evening, okay, or very good morning. What they call good day or good night, wherever you're on this planet. So, my name is Chong, Dr. Chong, from the Astronomical Society of Penang. So tonight we're having our regular end of the month airport virtual tour. Airport meaning Astronomical Picture of the Day by NASA. So we have here two of our members. I'll give them more introduction later. We have our Miss Boon Wei here, all right, who's as a committee member of the society, and Mr. Rayan, member of the society. Okay, so Rayan is in KL, Kuala Lumpur, the capital city of Malaysia. Boon Wei and me, we are from Penang. All right. So basically, this airport session is a bit special because this is close to the third year of airport. We started airport in May 2020. So in another 4 months, we are 3 years old, and really like it because a lot of pictures from airport we present. All right. So tonight we have with us me and Boon Wei, and then Rayan. We have our other member live, not with us. He was the one who chose the pictures. So we are presenting the pictures that he chose. And of course, another of our hosts here is Mr. Michael Teo. All right. So I will start off by giving off the what you call the first picture. Okay. Can both of you see my screen?
Yes, I can.
Yeah. Okay. So yeah, astronomical picture of the day by archived by NASA. So basically, it started in 1995. So these airport pictures, Rian is older than you. No, I don't as old as Bumi or not. We are yeah 25, 27 years old. Okay. So for today, 29th of January, we have this one, Barnard 68, dark molecular cloud. We're going to it. Oh, it looks a bit big. I'll reduce the size of the screen of the window. Okay. Then I'll read for you here. So this is on the 29th of January 2023. And you see, look, this is a heart-shaped absorption cloud but inverted 90 degrees. Okay. This is our dark molecular cloud, Barnard 68, and force steam. Force meaning something like focal reducer at very low dispersion spectrogram of the VLT. This is VLT Antu, not Hantu, Antu. VLT being the very large telescope of the European Southern Observatory in Cerro Paranal in northern Chile, Atacama Desert. There's the four big telescope, all right, and each of them is 8.2 meters. This is one of them, Antu. Antu in the local language called Mapuche means the sun. So the four telescopes are Antu, Guiyan, Maripal, and Jepun. Okay, so here basically the question here we say, so this is taken by the big telescope, no, of the ESO, European Southern Observatory in Cerro Paranal in South America. So they say, where did the stars go? This is a hole in space. So basically, this was an enigma in astronomy for quite a long time. So when telescopes were invented, they look at this part of the sky, which is in the constellation of Ophiuchus. So Ophiuchus is a constellation in the equatorial sky, and you observe, hey, there's a black spot here. So initial suspect by the astronomers was actually there's no stars around here. You see a lot of stars, but there's a black spot here. There's an empty space here. No stars at all. There's this empty space. It was much later, then we realized that not true. Here is where you have a lot of the dust and gas block up the light from behind. All right. So this is a kind of dark absorption nebula. All right, like this. And this being Ophiuchus. Ophiuchus also got another famous dark nebula called the Snake Nebula, also similar to this. So it's like the dust and gas will block the light from the stars behind. All right, it looks like a hole, but it's not a hole. It's full of dust and gas. Okay, block up the light, and you can see a bit of red cut up type of stuff, which means that those light that mix up of the infrared, so the wavelength of the infrared, which is longer than the particle size of this dust cloud, then the infrared light can go through. But visible light, the wavelength of visible light is shorter than the particle size, is blocked by the particles here. Right? So in infrared light, you can see through, but in visible light, you don't see through. This is called a dark nebula. All right, taken by the very large telescope in South America. We look at the next picture. 24th of January. Okay. Here is LHS 4475b, an Earth-sized exoplanet. So this is actually an exoplanet depiction. It's not this here. Look carefully, Ryan and Bunwei. Deep AI fantasy world generator. I went to this web, really amazed. So what is this? There's an echo. So is it that this deep AI fantasy world generator, you type in some words, it will generate for you a fantasy world. So basically, you have the telescope on Earth, have discovered that there's a star here, LHS 475b, okay, which is taken by this James Webb Space Telescope, okay, in the constellation of Octans. Remember, Octans is close to the south pole, So look at the sun direction. So this is LHS 475b. Small b is this one. So in exoplanet terminology, B is the first exoplanet. I repeat again. LHS 475 is the star. 475b is the first exoplanet. But if this star has two exoplanets, it will be LHS 475 B and C. Right? There's no A. A is the star itself. So this is kind of, you can say it's kind of space art generated by computer. This is the red dwarf star, and this is the planet. What is this? That this planet is close to the size of the Earth. Okay, 0.99 times the size of exactly the size of close to the size of the Earth, or about the same mass. And there's a lot of this speculation made whether it can have life. Okay, and then it's taken by the test what they call satellite. Okay, earlier, but this particular what they call view was the information was taken by this James Webb Space Telescope, and then they found that on this James Webb Space Telescope also supposed to detect atmosphere of exoplanet, but it found that it doesn't have those what they call other gases like methane and so on. Maybe we have this water vapor there. Okay, so this is this LHS 475b in constellation of Octans. All right, taken by the information taken by the James Webb Space Telescope. We go to the next one, 23rd of January. This one. Yeah. No. So the colliding spiral galaxies in UP 274. UP, of course, is our famous American astronomer Halton UP. Right? Halton UP, he actually in 1966 came up with a world famous Atlas of Peculiar Galaxy. So in the Atlas of Peculiar Galaxy, a lot of galaxies look very funny. Like this one, they look like joined together. And so basically now we know like these are three galaxies in collision. There's a spiral galaxy here, but look at the spiral arm on the right side. It's twisted. It's as if the spiral galaxy is rotating anti-clockwise. But in the center, this spiral galaxy seems to be rotating clockwise, and they are colliding. And far to the left side is another galaxy. So these are the three galaxies in collision, and of course taken by NASA, ESA, and Hubble. So basically, it's taken by Hubble Space Telescope and processed by our medical doctor from Turkey. Interesting, And he's basically an image processor. So what is taken by Hubble, sent to Dr. Mehmet Hakan Ozarak of Turkey, and he processed it. Very famous processor, image processor. And so basically, this is a case where two galaxies collide, all right? And it's the constellation of Virgo, 400 million light years away, not very far away, okay? So, and then, of course, you see that these are the diffraction spike of the secondary mirror holder of Hubble. This is 4 spikes here, okay? And then you see here that basically you see that when the galaxies collide, you see the pinkish color one in the spiral arm, and sometimes you have the blue knots. These are called the starburst section in this spiral galaxy. So here, the new stars are being born at a furious rate. A star being born at a furious rate doesn't mean like in a human hospital, every day maybe some babies are born in a city. No. Of course, stars take many years to be born, but comparing with the rate of birth of stars in other galaxies, is very fast. Many stars are born at a furious rate here, pink colored knots and the blue colored knots, right? And of course, when they collide, it's not like two motor cars will collide bang like that, all right, in a fraction of a second. No, because you remember they are interacting because of gravity. So basically, what is happening is that these masses in this galaxy will generate gravity waves, or even better, the and what is a gravity wave? It's a motion of the curvature of space-time. So motion or curvature of space-time is a motion of gravity, and gravity moves at the speed of light. So this travels at the speed of light, but because these galaxies are hundreds of thousands of light years in diameter and so on, so it's very slow, looks like a small slow dance. So it will interact, and maybe after hundreds of millions of years, they will merge into one galaxy, including the center of the galaxy. And now we know that a supermassive black hole is a must in every galaxy in the universe. So the two supermassive black holes will merge and orbit around each other. Okay, so that's very nice. Colliding spiral galaxies in up to 7. Before I end, Halton Up, you read his history, very, very interesting. He's one of the few famous astronomers who didn't believe in the Big Bang. He got an alternative theory of the Big Bang. All right, so he was a controversial figure. So Halton Up is famous for coming up with atlas of peculiar galaxies, and one of them is up number 274. Is these three colliding galaxies? Okay, so I now pass to the next presenter, Rayan. Over to you.
Thank you, Dr. Chong. Okay, let me share my screen. Can you hear me?
Yes, we can hear you. We can see you.
Okay. Can everyone see my screen?
Yes.
Perfect.
Good.
Okay. The first image I'll be presenting tonight, or today, wherever you are, as Dr. Chong said, in the world, is the astronomy picture of the day for January 21st. Naked Eye Comet ZTF. So what are we looking at here? Let me scroll down so that we can get a better look at this. Oops. One moment. Okay. So what do we have here? Well, let's quickly go through the image credits. The image was taken by Oscar Martin Mesonero. He is the founder of the Salamanca Organization for Astronomy and Space, for Aeronautics and Space. And he's been an amateur astronomer for over 20 years. And he's responsible for the image that we see here. So, what is going on in this image? Well, it's of a certain comet. As you can see, the name of the comet, which is written right there, Comet C 2022 E3 ZTF. It was discovered in March of 2022 in California. And the significance of it right now is that it is extremely close to the sun and to Earth, as a matter of fact. You see, its orbital period is over 50,000 years. Let that sink in for a moment. It takes it over 50,000 years to orbit once around the sun. So it comes deep from within the Oort cloud. And what's happening here is that this image was taken in Salamanca on January 19th, during a time where, because right now it can be actually seen with the naked eye, assuming you have little light pollution, you can actually see it in the sky. And on February 2nd, it will be coming extremely close to Earth. Now, in astronomy, when we say extremely close, we don't mean a few kilometers. We don't mean it's going to hit Earth. No. What we mean in this case is 40 million kilometers, which, mind you, is close because remember, 50,000 years of an orbital period. Now, 40 million kilometers, it's not as close as the moon is, but it is closer than any other planet in the solar system. So it is pretty close. For those of you who use imperial units, that would be that would be about 24 million miles. Now, although you can see it with the naked eye, only with a telescope can you truly appreciate that beautiful coma and the comet tail. So that's the APOD for January 21st. Let me jump to the APOD, my next APOD, which is that of January 8th. that load for a while. Okay. Now, comets are but one of a seeming infinite list of astronomical phenomena. Here, we're going to learn about a few others. Now, this image, which has taken an abnormally long time to load, was uploaded to Wikipedia, as you can see there, by a user named CMGLEE, or CMGLEE. I'm going to refer to them as CMGLEE. It's a code name, a username of a hobbyist illustrator who's interested in scientific, mathematical, technological, and architectural diagrams. And this diagram here is a prime example. It was taken using data by Professor Jennifer Johnson, an observational astronomer working at the Ohio State University. So what do we have here? We have, well, I think most of you will know, a periodic table. Nothing too fancy, right? Except it's weirdly colored. Why is it colored? Was it the work of some 2-year-old given computer graphics tools? Well, no. I mean, maybe. We don't know how old CM Glee is. As I said, we don't know who CM Glee is. But for the sake of this, and given it's more likely, let's just assume it was someone who had the data and made up this color coded graph. So, why is it color coded? Well, the key to it is right up here. These 6 events. You see, what we have here is the periodic table with each element color coded based on how and where they come from. So basically what this table is telling us is that each element, we know it has to come from somewhere. So which event, which astronomical, astrophysical event led to that element being created? Now, a lot of these revolve around stars, so let's do a very quick dive into how stars are formed and, well, the death and the evolution of a star. Let me see. Can I return here? Okay, I'm going to stop presenting for a while so you can see me. So, what happens with a star? Well, we know the basics of a star. You've got hydrogen fusing together into helium. Now that's a main sequence star, and all stars usually go through that main sequence phase in their life. What happens after that depends on their mass. So let's say we've got a low to medium mass star, say something with less than 8 times the mass of the sun. By the time it uses up all its hydrogen, because it will, you don't have an infinite amount of hydrogen, you have a finite amount of hydrogen. So by the time all the hydrogen that's used that has been fused into helium until there's really no more to fuse, the core starts to contract. And because the core contracts, there's a higher temperature, more pressure, allowing them to fuse even more hydrogen, causing the shell of the star to expand. So the core is contracting, the shell is expanding. Now, after about 1 billion or so years, the star, now what we can call a red giant, is no longer a main sequence star, it's now a red giant. The temperature and pressure become enough for it to start fusing helium. So helium becomes the primary fuel. It's no longer hydrogen, it's now helium. And the star becomes smaller and hotter. Eventually, that helium will then fuse into carbon and oxygen. So right at the middle, the very inner core of the star becomes carbon and oxygen. Right outside of it is a core shell of helium, and right outside of that is hydrogen. And then over the entire thing is the actual shell of the star, what you see of the star. And by this time, there's no more material, and the pressure and the temperature become high enough that the core itself and the shell shrinks together and expands. But the core shrinks and the shell expands. And that shell continues expanding until you can sort of say it's gone. It's no longer with the star. That shell material turns into a planetary nebula. It doesn't really have anything to do with planets. It's just a name that was caused by some confusion in the past. We'll leave that at that. The planetary nebula, that's what we get. And the core becomes a star, something we call a white dwarf. So that's what happens with a low to medium mass star. It's more exciting when you have a bigger star, a much more massive star, something that's over 8 times the mass of the sun. So what happens? Similar star, hydrogen runs out, core contracts, higher temperature, more hydrogen is fused, causing the shell to expand. But now we get a red supergiant because of the mass. Now the mass is so heavy, in fact, that the pressure and temperature start to fuse the helium quicker into carbon. The carbon then fuses into oxygen. The oxygen now, it doesn't stop there. The oxygen turns into neon. The neon then fuses into silicon until finally the silicon fuses into iron. Now, iron is extremely stable. It's stable enough that fusing it anymore won't give you any more energy. So, with nothing else to counter the effects of gravity, but what happens? The red giant collapses and explodes into a supernova. That supernova will end up with some supernova remnants, but what's left of it? If it's less than 3 times the mass of the sun, it becomes a huge ball of neutrons, something we call a neutron star. If it's over 3 times the mass of the sun, it becomes a black hole. Now, with that, let me return to the image and we'll try to understand. Oh, what is this? One moment, and we'll try to understand.
Share our screen again.
Yes. Um, okay, can you see the screen?
Yes, I can see it.
Okay, great. Now, January 8th. Where did it go? Okay. So, as the image says, where your elements came from, let's have a look and try to understand each of these effects. So, starting off, I'm going to go from, let's change this up, bottom right to top left. So, starting with exploding white dwarfs. So, what happens? Well, white dwarfs can sometimes end up in a binary star system, meaning you've got a white dwarf and you've got, say, a red giant. And the white dwarf, because of its immense density, because of its immense gravitational attraction, and its immense mass, it starts to pull from the red giant. It's literally eating up the red giant until eventually the white dwarf steals enough fuel until fusion in it reignites. And that sudden surge of energy just blows the star apart in something we call a nova. Not a supernova, just a nova. So that's what exploding white dwarfs are. And they explain, as we can see here, for for a certain amount of the copper and the iron in the universe and the argon in the universe. So that explains some of them. So that's exploding white dwarfs. Now we can also see near where exploding white dwarfs are a lot of yellow. What is that yellow? Exploding massive stars. Now that is what we covered just now. An exploding massive star is just when a red giant explodes, aka a supernova. Now let's get to some slightly more interesting stuff. Let's have a look at what the purple are. Merging neutron stars. Now you see, before neutron star collision was properly understood, a lot of these purple were assumed to be the results of supernovae. But now that we understand slightly more about neutron star collisions, we can see that a lot of the other elements that we have, gold, for example, comes out of these neutron star collisions. So what happens? Similar thing to the white dwarfs, we have a binary system. So a neutron star and another neutron star orbiting around each other. As they orbit, they're emitting vast amounts of gravitational waves. In doing so, they lose energy. As they lose energy, they move closer and closer and closer together until they collide. And when they explode, you get not a nova, not a supernova, a kilonova or a macronova. And that explosion is what gives us a lot of these other elements like gold, as I mentioned. So that explains merging neutron stars. Now, what about dying low mass stars? Well, that's basically the planetary nebula that I explained earlier. Now, the one that gets a little tricky is cosmic ray fission. But that's basically just cosmic rays impacting atomic nuclei. And they explain for a small amount of the elements, mainly, as we can see here, beryllium and boron, a little bit of lithium, but mainly those two elements. Most exciting, you could say, from some points of view, is Big Bang fusion. Talking about the early universe. So what happened in the early universe? We had primordial soup, basically particles going around, but it was so hot and so and the temperature and pressure was at such a high level that it was not enough that these particles could not fuse together. So we had just quarks floating around until eventually they became protons, and we got it, and well, electrons were already there, and then we got atoms, and from there hydrogen and helium came about. Those are the only few hydrogen, helium, lithium um, that came directly from the Big Bang. The rest of it, the majority of it, very much came from stars. Now, before I get to my ending for this image, I'd just like to note you will see that some of the elements have been blanked out. As you can see here, these are not color coded, and all the elements after atomic number 95 are missing. That's because those are artificial. They are not. They were discovered and have been generated artificially. But as I was saying, most of the elements we have, most of life and the elements in life come from stars. And there was a quote that was attached to this image that I think is especially powerful here. Carl Sagan once said that the nitrogen in our DNA, the calcium in our teeth, the iron in our blood, the carbon in our apple pies were made in the interiors of collapsing stars. As you can see here, most of these were stars that were dying, that were collapsing. So we are made of star stuff. Now, on the topic of Carl Sagan, I'd like to introduce you to my last image.
Wait a minute, Rian, can I add on to what you say?
Yes,
I really,
absolutely.
I really like. Please put back the velocity table again. Back
One moment.
channel
Oh,
8. I really like your presentation because in our presentation before in many schools in Penang, we say something. You check out boys and girls, what is this? Apple, sir? Apple, yeah. Do you know how apple is made? Of course, the general comment is apple is made of star stuff. So what's inside the water? In the apple, water, H2O. The hydrogen in the water, in the apple, in the water came from where? The Big Bang. The water in this mineral water bottle came from the Big Bang. What about the oxygen? Oxygen you see here is actually from the dying low mass star, like our sun. Came from the sun like a Pleiadian nebula. Okay, ladies, girls, where the gold comes from? Merging neutron star. So in other words, anytime you touch your body, you go anywhere, shop, you drive your car, anything you see, tell yourself which part does it come from? Is it Big Bang? Is it what and so on? I really have a nice picture of the whole thing. Okay, so just to make it better, so basically it's called nucleosynthesis. You're synthesizing the nucleus. No? So we have this here Big Bang nucleosynthesis, stellar nucleosynthesis, supernova nucleosynthesis. That's what it's about. Okay, very nice, huh? Rain, you continue.
thank you, Dr. Chong. Okay, now on to my last image, the New Year's image. So what do we have here? As I mentioned, this image also relates to Carl Sagan. Now, some of you may immediately recognize this. If you're watching this live or online with a friend and you know it and your friend doesn't, let the friend enjoy this brief period of time before they are amazed at what was accomplished and what this image truly means. I will give it some time to load. But just some background related to this image. This is a really big image. I'm going to have to zoom out quite a lot. Okay. I'll zoom back in later for an important part, but we'll just leave it there for now. So there's the image. Now, as I mentioned, this has to do much with Carl Sagan, and we'll get to that in a minute. But first, some backstory. It was the 5th of September, 1977. and the Titan 3E was launched from Cape Canaveral, carrying a 700-kilogram spacecraft set for a long, long journey through the space through the solar system and beyond. In hopes of reaching extraterrestrial life, the spacecraft housed the golden record with images and sounds from our planet. The spacecraft I am talking about was, of course, Voyager 1, as you can see credited over here. Well, it's a little bit small, but the image credits here are given to NASA and Voyager 1. Now, in 1980, 3 years or so into its mission, Voyager 1 passed Saturn. And Carl Sagan proposed to take an image. It would hold little to no scientific value at all, but would hold immense social, cultural, and humanistic value. Due to concerns of damaging Voyager 1's imaging systems, instrument calibration, and personnel layoffs, however, the project was put on hold until about, let's see, 1980s, until about 1989, when it was restarted, and eventually this image was taken on Valentine's Day 1990. I suppose you could call it a Valentine's gift to humanity.
So, Ryan, can you point where's the exact the Earth? Your cursor?
We'll get to that, Dr. John.
Cannot see. It's so insignificant.
I know. I'll zoom in a moment, and we'll get to that. So, I had a whole introduction here planned, but Dr. Chong did mention what it is that we're looking at in this image. To tell you what,
She cannot see.
I'll zoom into the whole thing.
There you are, can see.
That's some of you may know what it was. Some of you may have heard what Dr. Chong said. But on the off chance that you didn't hear, that is the largest rock in the solar system. It's not an asteroid, it's not a comet, but it's something that we are familiar with, very, extremely familiar with. It was formed in the early solar system not long after the sun, and has orbited around the sun for close to 5 billion times, spinning around its axis around close to 400 times every orbit. Early in its life, another large rock smashed into it, and the remnants formed a satellite which now orbits that big rock around 30 or so spins. Now, Carl Sagan referred to it in this image as the pale blue dot. The rest of us refer to it as home, Earth, as Dr. Chong mentioned. That right there is Earth as seen from Voyager 1. You watching right now are on that dot. I am on that dot. Everything you see is on that dot. Now, Carl Sagan summarized the importance of this image better than I ever could. So I'm going to now unshare my screen. Well, yeah. I'll tell you what, I'll leave it there so that everyone else can enjoy it. But I'm going to read an excerpt from his book, The Pale Blue Dot, on why this image is truly so profound. From this distant vantage point, the Earth might not seem of any particular interest. But for us, it's different. Consider again that dot. That's here, that's home, that's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, Every saint and sinner in the history of our species lived there on a mote of dust suspended in a sunbeam. Thank you. Oh, oh my God, it was so high. Okay. Um, I believe then next is Dr.
Next
Chong.
is Brother
Yeah.
Chong.
I go to January the 20th. Thank you, Ryan. Okay. We are waiting and anxiously for Boonway also. Okay.
Yeah.
January the 20th, 2023. I'll read up for you. Now, it says here, not Star Wars, Galaxy Wars, M81 and M82. Of course, M81 is the object on the right side, and electrical galaxy M82 is on the left side. Okay, so basically, when you say galaxy war, basically what a collision of two galaxies. This is a spiral galaxy. The one on the left is also a spiral galaxy, but seen edge on. Okay, so basically that these two galaxies are in collision. Okay, and then it says that it's the constellation of Ursa Major, 12 million light years away, and taken by an Austrian astrophotographer, Herr Andreas Abschneider. Okay, so basically, it's saying that these two galaxies, they have gravity and they're interacting. This is just a bit repeating what we said earlier, but never mind. It's interesting because this one is two famous galaxies, M82 on the left, M81 on the right. So they are because of gravity they collide, and it's not like that. You see, so for example, in one galaxy you have hundreds of billions of stars, and this galaxy also hundreds of billions of stars. So the question many people ask me is it possible to have 100 billion stars in one galaxy, and 100 billion stars in two galaxy, and when they collide because of gravity, twang, 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 the stars in each galaxy will collide, and the two galaxies will fall down? No, but in space there's no concept of up or down, so they will not fall down. And basically like this, the space between the stars in the galaxy is very empty. And of course, the space between the galaxies is also very empty, right? There are a bit of molecular hydrogen and atomic hydrogen in the space between the stars and galaxies. So basically, when these two stars, these two galaxies, they come closer, even if they collide each other, it's impossible for the stars to hit each other. But it's the atoms in the interstellar space, intergalactic space, that will hit each other and will heat it up, right? So you generate some infrared and even generate X-ray. So don't go to where two galaxies are colliding, a lot of X-ray given off, and very impossible for the stars of the two galaxies to hit each other. But the stars of galaxy 1 and galaxy 2 will interpenetrate and they will move through each other. Okay, and the gravity will distort the shape of the galaxy. So the galaxy after collision will have the look of a short galaxy. Okay, so you have this galaxy, for example, on the right, will pull because it's a bigger galaxy, will pull streams of stars from the galaxy on the left. Okay, and the galaxy on the left, M82, is famous. It's called the cigar galaxy. If you look in the last and last year, it looked like a cigar, and it seems that this galaxy gives off the most infrared radiation in our galactic neighborhood. A lot of infrared. Okay, so this is a galaxy war. Okay, so I always tell our Penang students, boys and girls, welcome to our violent universe. Why violent? Galaxies are colliding, supernova exploding, two black holes are colliding to give off bursts of gravitational wave. So these are two galaxies colliding in the past and going to collide in the future, right? And already you can see some of the streams of the stars here in this big galaxy are being affected by the gravity of the other galaxy on the left. Okay, so we go to now January the 18th. This is interesting. MAC S0647 gravitational lensing of the early universe by Webb. Webb meaning James Webb Space Telescope. Okay, Webb being one of the early NASA, James Webb being one of the early NASA administrator. So basically, a lot of information here. Now, we must be aware that in the coming APOD session, we are going to see this type of picture very soon. That means what? You can see the deflection spike. You see here, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so these are the deflection spikes of the James Webb Space Telescope. So what's the deflection spike? So basically, there are okay, you look at this one, you have 1, 2, 3, 4, 5, 6, 7, 8. So basically, you have in the James Webb Space Telescope many beryllium mirrors of hexagonal shape. And because they are hexagonal shape, when you focus the light from the universe on each of the many segments of this hexagonal shape mirror into a point there, all right? So the hexagonal shape will create this type of 6 spike. Okay, 1, 2, 3, 4, 5, 6. And then you also have the two boom that hold the secondary mirror, and the two booms will create the 2 vertical spikes. So in the coming years, we are going to see this very soon. So you have the 6 large spikes and the 2 small spikes. That's James Webb. But Hubble only got 4. Right? The spider got 4. All right. This one is it. So basically, this is gravitational lensing, meaning that here, these are not stars. These are all galaxies, many galaxies, maybe about 10 to 15 galaxies here. What happened is, behind this group of galaxies, there are another group of galaxies behind which you don't see. So what's given off by the galaxy behind? Light, visible light. And as the light travels from those galaxies far behind it, as they come towards us, this in the foreground, these galaxies here, they are mass. And this mass will have more curvature of space-time. So basically, the light of the galaxy from behind will be bent by this foreground galaxy, and then we can see it. So where are the galaxies? You funny-looking galaxy, bent. The bent one, red band. And this is a bent one. These are the background galaxy that are bent by this. So it's called gravitational lensing because the gravity of this foreground galaxy will bend the light as if it's like a lens. For example, the first one was proved in 1919, more than 100 years ago, by a photo-solar eclipse in South America and Africa, and proved that the light from the sun, from the star, is bent by the sun, and made Einstein famous. Okay, it confirmed that the general theory of relativity by Einstein is correct. So this is confirming the general theory of relativity by Einstein. Okay, so really amazing. So this is by NASA, ESA being European Space Agency, Canadian Space Agency, DANCO from the STSCI. STSCI means the Space Telescope Science Institute. So boys and girls, the James Webb Space Telescope is controlled by STSCI, the Space Telescope Science Institute, which is also the same institute that controls Hubble. Hubble is still working. Okay, so STSCI control JWST and HST. Okay, and this Rebecca Larson, the astronomer from the University of Texas, Yu Yang Xiao is the Johns Hopkins University, and processing is by Alessa Pagan of Space Telescope Science Institute, and the text is by Michael Rutkowski, Ministry of Minnesota State University, Mankato in USA. Okay, and you see here, these are the images of the lens galaxy. Okay, very exciting. So basically, these are all cosmological objects. Okay, so you can count here. I can keep on counting. There are many streaks, you know. So you don't say, oh, this streak here is one galaxy, any galaxy again. No, maybe this streak here is another part of the lens light from the same galaxy behind here. So these two and this one are from the same galaxy, and maybe this one are from the same galaxy behind. So the light is not only bent by the foreground galaxy, the light of the background galaxy is split into a few. So this is very cardboard, not this confusing. So like this. So this is proven that we are living in not only a violent universe, but also a weird universe. Okay. So now this is 13.26 billion light years away. This is a foreground galaxy, and this is the galaxies here are about the first general galaxy after the Big Bang. So this is only about 427 million light years after the Big Bang. Okay, so remember yesterday our Dr. Ting Yuan Seng, our Malaysian astronomer from Australian University, gave a talk. I attended a talk in our Sabah roadshow of the GMAC 2023. He said that the data, this is taken by James Webb of the new galaxy, create a kind of new information, because they thought that originally they didn't expect to find so many new galaxies just after the Big Bang. But the James Webb Space Telescope, in less than half a year of working, have found many new galaxies which are very old. I mean, the oldest galaxies in the universe, more than what they expected. So they are going to have an IAU conference next week to discuss this new discovery in Malaysia. IAU conference, International Astronomy Union conference in KL next week. Okay, so we go to the next one. 17th of January. I'll read out. Of course, I when I saw it, I realized this on the right is of course our neighboring galaxy Andromeda. Okay, and it's taken by what they call this French amateur astronomer. So unexpected cloud toward the Andromeda galaxy. Which is Andromeda galaxy on the right? The unexpected cloud is here. The blue one. So basically like this. This is totally unexpected. The blue band of light, okay, the blue-green band of light is that is unexpected cloud towards the Andromeda galaxy. So this amateur have been taking Andromeda galaxy and the satellite galaxy of Andromeda galaxy years ago, right? But they didn't realize that next to Andromeda there's also the. So later on they suspect that they want to see whether there's more to Andromeda galaxy than what is done. So they took the a special filter by amateur astronomer in the blue and green region by our Monsieur Jan Senti from France and Herr Marcel Dressler from this Germany. Okay, and they found this, and they were very surprised because they never expect this. Then they realized that other than Andromeda galaxy, there's a lot of this gas or whatever plasma, whatever that created this. So this is our O++, O being oxygen, doubly ionized oxygen clouds. And they also, this excited plasma will give off O++, excited atom will give off the green-blue light. Okay, and this is totally unexpected, right? So what I'm saying that even amateurs can make discovery now, right? And because this has been seen maybe in a different wavelength, so it's not the usual look of Andromeda galaxy. It could be in the infrared. Okay, Andromeda galaxy in the infrared. Okay, and later on, to be sure, they asked the other amateur astronomers from around the world to take picture of this Andromeda and see, and using the same filter, and the other astrophotographer around the world also got the same image. So now this is a real effect, not because of the French amateur astronomer, but it's a real effect, and this is a big surprise, But then you may say, but the big observatory, how come they didn't discover it like that? Usually the big observatory, high magnification, they focus on one object here and study, another object here and study. They never focus on the whole thing. So this band of blue-green light is a few moon diameters. So amateurs may have time to do this imaging, maybe many hours or many days to get this. But the big proportional observatory will focus on smaller objects because the focal length is longer, high magnification. They have no time to image this big object. So in other words, the amateur astronomer can still make big discovery. Okay, we go to the next one, 14th of January. So I read here, perihelion of the Sun, 2023, copyright Peter Ward, Baden Ridge Observatory. We know Peter Ward is, of course, a well-known Australian astrophotographer staying in Sydney, right? Capital city, in New South Wales, capital city of New South Wales, and in his own private Baden Ridge Observatory in Sydney city itself. So basically, you see the sun. Okay, you can see all the prominences. The prominences here, and you can see some of the bright places, and also you have the sunspot. But it's at perihelion. Okay, so basically, is here it says what is the date here? Is on January the 4th, at Malaysian time. So Malaysian time should be January the 5th this year, on 17:00 a.m. Okay, that is when the sun is at perihelion. The sun is closest to the no, the Earth is closer to the sun. Therefore, the diameter of the sun should be the largest. And someone said, how come? January is the northern winter, isn't it? By right, if the Earth is closer to the sun in this January, it should be warmer in the southern hemisphere. It's quite true, is what they say. When the Earth is closer to the sun, it should be warmer. But what happens is there's a tilt to the spin axis of the Earth, 23.5 degrees. There's a tilt in the spin axis. So in the northern summer, the northern hemisphere is pointing away from the sun. So the northern hemisphere will get less light. Therefore, it is colder. But actually, because the Earth is closer to the sun in January, it should be slightly warmer. But the decrease in the temperature when the Earth is closer to the sun is much less than the decrease in the temperature by the tilt of the Earth as it goes around the sun. So that's it. So this is our what they call solar perihelion picture of the sun taken from Australia. Okay, we go to the next one. 13th of January. This is our in the SMC. Repeat. Young Star Cluster NGC 346. Okay. Again, I repeat the image credit. Yeah, NASA, ESA, CSA. Or the CSA is, of course, Canadian Space Agency, ASA, European Space Agency, and Olivia C. Jones, a woman astronomer in Royal University of Royal Observatory of Edinburgh. Okay. And then your Guido de Masci is what you call Italian astronomer. Margaret Messner, a famous astronomer, American woman astronomer in US, what they call RA, University Science Research Association. Okay, and it's processed by the same girl, Alisa Pagan, SCSCI, Space Telescope Science Institute, the Institute for JWST and HST, Nolan Hable, USRA again, USRA here, Laura Linky, USRA, Laurie EU Chu, NASA Ames Research Center. So basically here, they point the what they call the telescope, okay, at this what they call young star cluster in the small imaginary cloud, and you can see the star what they call star clusters are all here. They are the young stars, and then you see here what you see here, 6 5 plus 2, James Webb Space Telescope. That's taken by James Webb, and there are a lot of new discoveries here. Okay, so in the infant star, a baby star, only 3 to 5 million years old. 3 to 5 million years old, very young. Yes, in astronomy, 1 million years is very young. 100 million years is not still young. Half a billion years old, okay lah. 4 billion years old, average age. So 3 to 5 million years old star is very, very young, baby stars. Okay, so a lot of information here by this James Webb Space Telescope. And again, this is when the James Webb Space Telescope just launched, and so much new data they have already obtained. Okay, next picture, 11th of January. Oh, don't be scared. Oh, yo. Okay, I'll reduce the size of the picture. Wait, reduce again. Okay, so basically, this is by our Italian astrophotographer from Italy. Went all the way to Iceland and took a picture of the aurora. So this is the landscape. Sorry, these are all rocks. These are not human skulls. Each rock is about 1 meter in diameter, and this interesting rock formation. And in the sky is the aurora. Okay, and then they say Italian astrophotographer Stefano Pellegrini went from Italy to what they call it, Iceland. And remember, Iceland is a group of islands to the north of England, north of Scotland. And I think it belongs to, is it Denmark? Is it Denmark or Norway? Okay. And he took a picture, and he must, first of all, this is my hike to to this remote area near the sea, and you will say, hey, how come there's a mist in the sea? So no. It basically, it took a long exposure, maybe 1 or 2 minutes exposure, so that it can expose the aurora better. And because of long exposure, so the waves on the sea, the turbulence in the wave look as if it's like a mist on the water. It's not a mist. You take a long exposure, so the wave altogether smear out, form like a mist, but then you have also the aurora in the sky. Okay, beautiful and look like a spiral aurora. This is my spiral galaxy, in the Earth's atmosphere. And don't be fooled, oh, this aurora is just 100 meters above the rock. No, the aurora is close to space. Remember, space is 100 kilometers from the Earth's surface and higher. This aurora could have been created 80 kilometers from the Earth's surface, high up in the Earth's atmosphere, close to space already. So already far, right? And then you can see that, what is this? That the solar wind particles, this is what? Electrons and protons that are blown off from the Earth's photosphere, that travel at a fast speed, right? Many hundreds of kilometers per second, and they come towards the Earth, and the Earth has a magnetosphere, magnetic field lines, and the magnetic field lines will channel the solar wind particle, electron and proton, over the north polar region or south polar region, and as they enter the outer atmosphere, will hit the end molecules in the outer atmosphere of the Earth, which will kick off the electron from the oxygen molecule or nitrogen molecule. So kick off, say you kick off the electron from one of the outermost orbit of a oxygen molecule, and what happens to the electron kick off? The excited state must become neutral again. So another electron passing by will fall back and cover back the excited electron. So when it cover back, you emit light, and because the energy levels of the electrons of the oxygen molecule and nitrogen molecule are all quantized in discrete level. So the light given off by this de-excitation of the energy level, we have discrete energy level. We have light in different color, green, red, and blue. Okay, and then if I enlarge it, you can see also it's not just like that. Basically, the star behind the aurora can be seen. You enlarge it, you can see the star behind. There you are. You can see some stars here. You mentioned here Polaris, but I was looking for Polaris, cannot see. So basically, you can see the stars here also. There you are. So basically, this guy must be very adventurous, He must have hiked to this location and found this nice location. And what did you do? Wait for the sun to set. And if this is being January, winter, 24 hours night in Iceland. Because in winter, you don't see the sun in Iceland. So maybe you can see it. Maybe he took it at about 3 p.m. Iceland time, 24 hours night. And then he was able to get the spiral aurora. It's not a real spiral galaxy, This is inside the Earth atmosphere. Okay? So we go to the last one, my last picture, 9th of January. So similar to what our Rain was saying earlier, okay? So the name here is Tails of Comet ZTF. Okay. ZTF is, of course, okay, this comet C/2022 E3 ZTF. Okay, so basically, this is taken by Jose Francisco Hernandez. He's an amateur astronomer from north of Spain. He took it from his observatory north of Spain, facing the Atlantic Ocean, and he took the picture of the comet. Okay, from this Altamira observatory, and this is a famous one. Actually, tonight I understand magnitude 6 already, or brighter. Can see with naked eye. Okay, so if you know where it is, try to look for it. So you can see 3 tails here. Okay, and we know that this comet was perihelion of 12th of January recently this year, and closest approach was 1st of February. Okay, next week, closest approach. So the best time to look for this comet is from now to maybe in another 2 weeks time. Don't miss it. Okay, so you see here the green line, and you can see the three tails. So if you look at the comet, many times when I ask the people, where is the comet moving? And the comet is moving down. Then this is the rocket exhaust from the comet. Comet, where got rocket exhaust one? So this is like that. The sun is below this comet. He's right below here. So sun is at the bottom left. So the sunlight, which is the electromagnetic radiation, and the solar wind will hit the nucleus of the comet. Remember, the comet have three parts. The nucleus, which is the solid part, which is the frozen and ice and dust, the nucleus. And then as the sunlight and the heat and the solar wind hits onto the nucleus, the frozen ices will evaporate and expand to form the head of the coma. So the nucleus is the first part, very small. The nucleus can be 10 kilometers in diameter. So the size of comet is just a tiny point. But the coma can be about few hundred thousand kilometers in diameter, because the frozen ice from a solid state, frozen material becomes a gas. The solid melted doesn't become a liquid, no. From a solid, it goes straight into a gaseous form and it expands to form the coma, very big, 100,000 or more kilometers in diameter. And then the solar wind, sunlight is still hitting on it. Then it will hit the particles, the evaporated particles, and create the long tail. Here got two tails here. Okay, three tails here. Okay, so these are the three parts of the comet: the nucleus in the center, the frozen part, and then the gaseous expanding coma, the head, and then the long tail, also gaseous. So like this. So why is it green? We know. So basically, in the comet, you have frozen ices and also what they call solid nature in the form of C2, diatomic carbon. Usually the carbon we have on Earth is a single atom of carbon. This is two atoms of carbon joined together. This is like oxygen 2. Two oxygen atoms combined together to form one oxygen molecule. But the two atoms of carbon joined together to form one carbon molecule. So the C2 and also our CN radical. CN means carbon and nitrogen. Cyanogen. Oh, poison. Cyanide, you know. Luckily, our Earth didn't pass through the tail of this comet. But then our Earth's atmosphere will be saturated by cyanide plasma. Dangerous, you know. Okay. So luckily, it's far away. So the green color is again because the light from the sun, the electron light, will hit the, what they call this, carbon 2 molecule and excite the electron, and they will de-excite and give up green light. And also excite the CN radical, cyanogen radical, to excite and de-excite, also give up green. Okay, and it's not one. The green light from this carbon, diatomic carbon and cyanogen radical are not one single green light. Many lights. It could be hundreds of lights, but our eye cannot discern that they all separate. We all see as if all green. But you have a spectrograph, the split it can be hundreds of green lines. All right, not just one. Many green lines. And here you see the background stars, and we know that this one is going to be in perihelion soon. Okay, next week, 1st of February. So we are going to observe it because we're going to move faster, and we hope we can see from Malaysia. So far, I have not seen any Malaysian taking photos of it yet. Okay, so after that, what happened? Like what Rain said just now by ZTF. Okay, so ZTF is our transient telescope. Okay, in America, in Mount Palomar Observatory, that took this picture. Okay, so now I will leave the next picture to Boon Wei.
Yeah, thank you, Dr. Chong.
Okay.
Thank you, Dr. Chong. I think I cannot open my video. My internet is quite not so stable now.
I can show the picture, but you explain.
No, it's okay. I can show the picture, but I think I cannot open my video.
Okay.
Yeah, no worry.
I can hear you well.
Okay, good. So if you cannot hear me, then let me know.
I can hear you.
Okay.
Yes, can see.
Can see my screen?
Very nice.
Yeah. Okay. So this is my first APOD to present. Hi everyone, happy Lunar New Year. So this is the 7th of January APOD, which is so this actually is not the meteor trail, and also it's not the aeroplane trail as well. It's actually this is the trail that what our space station, International Space Station, and the another one is the China Tiangong Space Station. So this picture is taken by the Jacques Palma. He's an astrophotographer, astro landscape, based from the Portugal. The two space stations were actually crossing now in the low Earth orbit in the pre-dawn sky of the 3rd of January. So low Earth orbit is an orbit that around the Earth with an altitude that lies towards the lower end of the range of the possible orbits, which around 2,000 kilometers or less. So during the LEO, which is the low Earth orbit, the space station will be close and near to the Earth, and this will provide a very spectacular vantage point to take the picture of our planet Earth. So normally the astronomer inside the space station will take this chance to take a very beautiful Earth picture when this time. So seeing across the starry background, you can see that the birth space station is moving from this is the west and this is the east. So they are moving from the left to the right. And the upper shell just below the Ursa Major is the China Tiangong Space Station. The Tiangong passes just below the inverted Big Dipper asterism of the Ursa Major, so near the peak of its bright arc, and then above the North Pole star Polaris. Okay, so before that, the less than 5 minutes before the CSS, actually there is the ISS also flying across the dark sky. So its trail is just above the Cassiopeia near the northern horizon. So this picture was taken about like an hour before the local sunrise from the from an abandoned mine at a place called Arcada do Camo in the southeastern Portugal. Yeah, very very nice composition, and actually this have to plan and wait for the both IS to come across at the same time and on the same under the sky. Okay, so
Very nice. So,
yeah.
Mumbai, allow me to ask one question. I ask myself lah. We have one spacecraft, ISS, and then another one, Tiangong Space Station, passing over each other. So imagine one of the person in one of the spacecraft put a head up. Can I hitch your ride? I want to hitch a ride or not in your spacecraft? In space lah.
Not sure.
Just a friendly way of saying lah.
Okay, so I will go to my next one is the 6th of January APOD. Yeah, this is the moon chart, the full moon chart.
Very nice.
So yeah, so on this day, 6th of Jan is actually the first full moon in this year as well. So but the APOD on this day is they put on the whole full moon chart in last year for the quick reference. So the day and the month, and also their traditional name like wolf moon, snow moon, and so on. That is relative to the seasonal markers are given in this clock chart. Right? Yeah. So this APOD is taken by Nives Kumar from Sri Lanka, and he is very dedicated dedicated project that he actually spent quite a long time to take this. The apparent size of each moon also depends on how close the full lunar phase is to the perigee, which is the closest the moon to the Earth, and will look bigger and brighter, and to the APOD, which is smaller and is far from the Earth and dimmer. So you can see the wolf moon is quite in small. So the wolf moon this year, which is also just happened in the 6th of January, is the furthest and the micro moon in this year as well. Is the first of the two micro moon in 2023. It's not the furthest full moon. It's the second furthest. Means the next micro moon, which is the February, the snow moon will be the furthest and the last micro moon in this year. So the next month will very very small. You if you look at the moon, you will feel, oh, why so small? Because it's the furthest. Okay, so a very special note in year 2023, like what say in here, we will have 13 full moon, so it won't fit nicely on the 12-hour clock. Yeah, so this year we'll have a blue moon. It normally happens every 2.5 years, meaning a second full moon occur within in a single calendar month. So this full moon will happen in the 30th of August in this year, and we'll have 4 supermoon in this year. So the date is in the July 3rd of July, and the 1st of August is the, and another one which is the blue moon also is the supermoon in this year, and another one is the 29th of September. So total 4 supermoon in this year. Yeah. So this year I think there is also a partial solar eclipse, but only can seen in the eastern United States. Yep. Okay, so I go to the next one, which is the 5th of January. Yeah. Okay, so this is a very beautiful Pleiades. Is actually the best naked eye deep sky object. I like the blue, so actually when I see this picture, I sent to like say, oh, this is nice. Then yeah, this photo is taken by Stephen Chun. He's a major astronomer, and his job is actually a German Air Force soldier. So he took this Pleiades. Okay, so this Pleiades is also well known as Seven Sisters open star clusters. So yeah, this is means the seven daughters from the Greek myth, from the Titan Atlas, and also Cleon. So this Pleiades is very very easy to see. It lies in the night sky towards the constellation of Taurus, around the Orion something, because he's actually from the Greek myth. You know, they are the Orion is the hunter Orion want to chase the seven daughters. You know, yeah. So Pleiades is about 400 light years away. Okay, so this picture features a pinpoint stars, and also the details filament of the interstellar dust captures taken about like 9 hours exposure. So it spans more than 20 light years across the Pleiades star cluster. But actually, the sister stars is actually not related to this dusty cloud. Just happen to be passing through the same region of space. So is actually well known with this striking blue reflection nebula, because the star will reflect the light of the surface of the pitch black clouds of cold glass, and then the scattered light is polarized and then have the spectrum similar to the star. So it appear in blue. Okay, so yeah. I think Pleiades is actually well discussed in the previous APOD. So let me proceed to my last APOD today. The last APOD I would like to I like to present will be the 2nd of January. So after the sunset planet parade.
Wow.
Yeah, you see this picture is very, very beautiful. Okay, so this is the full view. You can see it's almost all planets in the solar system happen at this hour in this picture. So it's a sunset picture taken by Tung Teaser. Is under the World at Night TWAN program. This picture is taken in a small village in Turkey, near the Mediterranean coast. So you can see, very nice, so beautiful. This is the sun is set, and then you can see the Venus and slightly dim Mercury here, and then this is the moon is visible, and also you can see the Mars and the Jupiter here, and but the normal less visible one is Neptune and Uranus. So it it couldn't be seen from our naked eyes, but it actually captured by the camera, because they are putting the long exposure. So you can see also the bright stars like the Aldebaran, and also this the Pleiades that I discussed just now, and also the former Hawk. So many stars, so
So nice.
beautiful. Yeah, so nice. I feel it's a very peaceful, that I would like to sleep under here or somewhere, and then looking at the stars. So it will be very enjoyable.
And
But-
Boon-Hwei, it's easy, Just drive your car. You know, on the left side is a road, You just drive your car. Maybe stay in the city in the distance. Drive your car up and park on there, and then take a picture.
Hello, yeah.
So easy.
And sleep there.
Can sleep
Enjoy
there.
the.
Enjoy.
Yeah.
Mhm. But normally, so many stars, I couldn't. I will feel so hard to
Yeah.
to know which star is which star already.
Yes.
Okay, so I think I see this kind of skies is in Cameroon, where we see why so many stars. Oh, wow, really? Then we totally cannot differentiate what star is that.
Yes. Wow.
Yeah. Okay. So that's all from me, all of my APOD. So let me check from the YouTube and Facebook.
Facebook, yeah.
Any question? I stop my screen first.
Rayan, show your face.
One moment. No, hold on. I'm trying to. Okay. Can you see me?
Not yet.
Not yet.
What about now?
Yes.
Okay.
Okay, now can see your nice picture. behind you.
Okay, let me try and open the my video.
Boon-Hwei,
This background is the space station. Yeah,
Yeah.
it's near to the Earth now. Low Earth orbit.
Very interesting.
Okay. I couldn't see any question from the ground from YouTube. Yeah, no question.
Maybe Rayan and Boon-Hwei, any additional comment you want to make? Okay. I think nice picture, all very nice, Very nice, huh? Yeah. Any additional comment?
No.
Rayan, your nuclear synthesis periodic table very nice, We can pay more attention in future. Like in like give out the talks, I follow with Apple. This comes from there. So
The Big Bang.
and then there's a particle of, let's say, a silver inside come from there. From, let's say, like you say stellar nucleosynthesis. Very nice, Yeah, we can ask them. So basically, our body is made up of what? About 70% water. And water is 2 hydrogen atoms and 1 oxygen atom. So a lot of the hydrogen atoms in our body came from the Big Bang. So you say we are the hydrogen atoms in our body are as old as the universe.
True.
We are directly linked to the birth of the universe. Yeah. Any comment, Boomer?
So fast, no.
Yeah.
Yeah, no.
Well, let us go and look for a dark place to do stargazing, Boomer.
Okay,
So far,
somewhere,
somewhere in Canada is possible. In Canada,
somewhere in Canada
Canada,
or police also.
yes. Again, I got a call from YB Gun Island yesterday,
Eh?
and also got a call from her about 2 weeks ago. She wants us to go back to do stargazing 29th of April, Saturday, 30th of April, Sunday, 2 nights, and also Monday, 1st of May, Monday, which is a holiday, in a dark sky location in Paris. You find a place for us to stay. Please mark in
Oh.
your calendar. And then she just called me last yesterday that she wants to build an observatory in somewhere near there. The first time,
Ah,
and I'm going to speak
that's
to
good.
I will speak to CK Chungchat tomorrow lah. Okay.
Yeah,
So,
okay, good. I think police is still the less light pollution place.
yeah. But when you
Yeah.
are with us to 2020, is it stargazing police?
Yeah, I
Ryan,
went.
were you with us in 20?
No, I was not.
We inform you if you can come this time in April, end of April, early May. Huh? Good.
Okay.
If you have another
That would
new
be fun.
site to visit lah, in Police. Huh?
Good. Okay.
So
So,
maybe
Dr. John?
you can end up wrap up.
Okay. Yeah, so thank you very much for joining us tonight. So tonight will be a fireworks show for the Penang guys, I think. So happy Chinese New Year, happy Lunar New Year. See you in next month. Bye.
Thank you, everyone. Brian,
Thank you.
thank you, Michael.
And thank you to everyone who
Thank you,
watched.
everyone. Yes, yes.